Cool. Hey, first off, thanks guys for taking the time and to come and listen to me. So I'll be honest, when I was trying to come up with a topic to talk about today, I find it really hard to nail something down, mostly because I haven't been consistently coming to, it's been a while since I've been consistently coming to these tech talks, and it's kind of hard to gauge the audience level, especially for a focused topic like iOS. So I knew I wanted to talk about iOS, but less about the day-to-day development nitty-gritty, and more about like interesting things that maybe are happening in the community that people aren't aware of. So real quick, how many actual iOS developers in the room? Semi. Okay, no, that's good. I assumed that there wouldn't be very many iOS developers, so I wanted to take a very high-level approach. Introduce you to some new stuff that I was assuming that you didn't know. So before we get started, a little bit about myself. Dustin touched on it, but I'm an instructor at Treehouse, so we're an online school. We teach everything from iOS development to Rails to Node, Android, all good kind of stuff. So if you're interested in learning iOS development or anything else, and you want to know more, feel free to ask me questions about Treehouse later. So in the iOS community, there was a big change last year. Apple took everyone by surprise when they introduced a brand new programming language called Swift. And I wanted to introduce Swift, talk about Swift a little bit, but more than talk about some of the details of the language and kind of the implementation details, I want to talk about why would Apple even introduce a new language to begin with, and what does this mean for the community, and how people have been reacting. And that is kind of my focus point. I like talking about change, and this has brought about a lot of change, so I want to touch on it. So prior to Swift, we had ObjectiveC. That was and still is pretty much the main development language for iOS development. And ObjectiveC is quite old. It's not old in terms of programming languages, but it's older than me, so it's old. ObjectiveC was came about in the 80s, I believe, 1983. So that's about 32-ish years old now. He's laughing at me. So it's been around a while. And because it's been around for that long, and because it hasn't changed much, ObjectiveC comes with a lot of legacy, or baggage, as a lot of people like to call it. It's a C-based language, so which means there's a lot of stuff that you have to do that nowadays the computer should just be doing for you, right? It makes it less pleasing to develop in. So so I want to touch on a few of those points, because those are some of the reasons why a lot of people have been complaining for a while about why we need to get rid of ObjectiveC. So being a C-based language, it has header and implementation files. Now, if you've never looked at ObjectiveC code, you have to define your objects or your classes or whatever. You have to declare the public interface in one file, often known as the header file or the interface, and then the implementation details of those objects or classes or whatever go in a separate file, an implementation file. And this means a lot of typing, a lot of code that in more modern languages you don't have to do. And Apple's made a ton of money and a lot of developers have made a ton of money doing iOS development, and so it's brought in a lot of developers from other communities into the iOS community. And a lot of those people come from a more development environments with more modern languages. So there's a frequent complaint, right, that we have to deal with all this old school stuff that we don't want to. Part of that old school stuff, this is not super clear, I was hoping it'd be bigger, but part of this old school stuff is the syntax. ObjectiveC has, when you look at it, some syntax that makes it look very outdated. So if you take that first line of code, we're declaring an array here and kind of sorting through it with the compare function. But the first keyword, so you have NS array. Well, what's NS? ObjectiveC doesn't have support for namespaces or having unique naming within a project, so you have to provide a prefix for all your classes to prevent collision with other objects. Then you have a little asterisk there. Well, what's an asterisk? Being an old C-based language, you have to deal with memories and pointers. So this array, we're not actually storing the array. That sorted attributes variable is storing a pointer, basically the address where that array will live. And so you pass that address around, and this is efficient. It allows you to store large objects without having to actually pass that object around. But so I spend my day teaching iOS, and primarily to beginners. And this is a huge pain in the ass, right? Not only do you have to learn about the language and programming, but you have to know about memory allocation and what's going on under the hood. And obviously Apple's thinking about these problems because they want as many people developing for iOS as possible, and these things prevent people from really getting hold of the platform. Then you have square brackets. That is how you I want to say call methods or call functions in Objective-C, but Objective-C doesn't actually call a method. But you use square brackets and you put the object and then the method you're calling, and that's the kind of syntax. And Objective-C was developed as like a superset of the C language, so you'll even see C API there, which gets even crazier. To take a look at how a more modern language deals with syntax compared to Objective-C, so this is how you would define a car class in Ruby. So you say class car, you give it an initializer method with 2 instance variables, and you just print some stuff to the screen. Every time you want to create a car in Ruby, you just call new, right? In contrast, in Objective-C, you have all sorts of crazy stuff going on. So you have that prefix. Typically, developers put their initials as a prefix, so mine's over there. Then some of the other crazy stuff. So where we're declaring our properties, so that the property lines, you have these qualifiers, these keywords, non-atomic and strong. Objective-C, being a lower level language compared to some more modern languages, forces you to think about like how your code operates when there's, for the more technical term, in a multi-threaded environment. So when it could be doing 2 things at the same time, which has more priority, if one writes some data while the other's accessing it, what happens? Objective-C forces you to think about all these things and makes it, again, really difficult for newcomers to understand the platform really well or write good code, right? That's all that, when Apple introduces a new language, that's primarily what they care about. Bug-free code so that their end users, the people who are paying them billions of dollars, have a great experience. And then, so this is the public-facing side of the class. Then you also have to spend time defining the implementation details. And then again, everywhere you have asterisks, you have to worry about a lot of technical details. And at the bottom, if everyone can see, like so in Ruby you had to call new. In this one you have to call alloc, which allocates a space in memory. Then you have to initialize it, and you're storing the address where that's stored rather than the actual car instance that you've created. So there's a lot of crazy stuff going on. At the same time, Objective-C is a powerful language, and it's done well. That's why people still use it. It's very dynamic. It's got a lot of like generic containers that allow you to defer programming decisions until runtime. So it allows, it provides a lot of flexibility. But all that into account, there are 2 primary problems, right? So when I was preparing this talk, I typed cons of Objective-C into Google, and the posts go far back. Right? There are blog posts from people complaining in like 2002 that the fact that Apple is using a language so that asterisk deals with the pointer addresses. The fact that Apple is forcing you as developers to think about memory and to think about all those things. So here's an example. These are all keywords that relate to memory management when you're writing Objective-C code. So every time you create an object, a lot of this has been simplified, but in very recent days, every time you created an object, you had to remember, okay, you're using this object right now, so we need to increase what's called a reference count. So you use all these different sorts of keywords, and you need to know, hey, I'm done using this thing. Like if I'm not using my car anymore, I need to get rid of it so that we're not using memory. And just in thinking of all these low-level details, it keeps people from being more productive on the platform. People complained that this was a competitive disadvantage for Apple, and in not changing these things, they were setting themselves up for a future where down the road, developers would flock to other platforms, Android, Windows, and thereby leave Apple in the dust, not because their products weren't great, but people just weren't willing to create good software for it. And Apple talks about it over and over. There's millions of apps on the App Store, and this is part of that product strategy, right? Having a tool chain and a language that allows you to create those wonderful apps. So I found this is from a blog post complaining about Objective-C in 2004, where they talk about all things being equal, when faced with 2 technologies, one that's less abstracted but more powerful. So this is Objective-C, right? it forces you to be quite low level. And the other more abstracted but slower one, the slower one, the more abstracted one, will always win because computers get more powerful. Computers can handle more of these problems as time goes on, but our ability to deal with the complexity doesn't, right? So in being forced to think about these things, everyone's going to migrate away from it. And that's not to say that Objective-C didn't change. So in 2005-ish, or 2006, Apple introduced Objective-C 2.0, and they brought a lot of things that simplified some of the problems I've talked about. And Objective-C, so at that point, Objective-C was at this tipping point where people were really migrating away from it. But then the iPhone came along, and at the time when the iPhone first came out, it was not a great CPU, low memory, and so Objective-C became useful again, right? So in using a language that was very low level, that allowed the developer to be very critical in how they used memory. It allowed, even on such a low-powered device, you could make great apps. And so, in the community, everyone says that the iPhone kind of went back in time to save Objective-C by being such a not so powerful device. But the iPhone has come a long way. So again, it's time to revisit that point and see why are we still using Objective-C. I put this up because this is one of my favorite examples of the crazy syntax in Objective-C. So this is how you define. These are all ways of how you define a anonymous function or a block or a closure, as they're called in different languages. This is all ways you do it in Objective-C. And some of this is because of legacy reasons that they're dealing with C, but it's just crazy. You need to remember all this when you're writing code. Most people don't. There's a website that has a not safe for work URL that you can go to read up this syntax every single time. And I think you know what I'm talking about. No? Okay. No.
I want to know.
It's just it's how to write effing blocksyntax.com, and there's a safe for work one. It's like gosh darn blocksyntax.com. But obviously, Apple was aware of these problems, and they were working towards a solution. But changing an entire programming language, especially after the iPhone was introduced, is a monumental task. So, prior to the iPhone being announced, had they sat down and said, "Okay, we're going to introduce a new programming language," the Objective-C code that was out in the world is a tiny amount compared to what is there today. And so, they would have had a much easier chance of doing so. If you look at different companies in the past, so Microsoft, they migrated from C++ to C#, and then Apple, when they went from OS 9 to OS 10, they had this bridge called Carbon that let you kind of, write code that worked on both. It took them, with Apple and Carbon, it took them 12 full years. So it was introduced in 2000, and in 2012 is when they got rid of Carbon. So it took them 12 full years of supporting that API to allow people to write apps that ran on both platforms. That seems crazy, but then you think about educational institutions that run apps on really old platforms, and yeah, you have to support these things for a long time. And so, while people were complaining that Objective-C really needed to go, there are a lot of considerations when you want to change such a massive thing. As part of being at Treehouse and teaching Objective-C development and all that, to a very large user base. So we have an iPad app, and it's featured globally the second or something on the Education App Store. And because of that, we're fortunate enough to get invited by Apple to meet the Swift language team right after they developed the language. It was a really cool experience because they talked to us about 90% of the things I did not understand, but they talked to us about some of the decisions they took when implementing this language and how long it took them. So one of the interesting things they said was that so when Objective-C 2.0 came out in 2006, everyone celebrated because it made a lot of syntax easier. It took away some of those problems that you had to deal with. And a lot of people now say, well, we don't need Swift because we have all those things in Objective-C 2.0. But the interesting thing that they mentioned at the Swift Summit, as they called it, was that all those improvements to iOS and to Objective-C and to Xcode that we have now is because they started working on Swift back then. So they started working on Swift in 2004 or 5. It was just a side project, and it started to come together. But they thought, okay, well, we want to write a new language where we really don't want the developer to think about managing memory. computers can do that nowadays, so let the language do this. And so they did that, and the language is powered by a compiler under the hood, and they wanted to use the same compiler for Objective-C and Swift. And so they thought, well, if we want this new language to use the same compiler, let's modify it so it can support automatic memory management. And then when they did that, they were like, okay, well, the compiler can do this, let's give it to Objective-C as well now. Let's hand off this ability. And then they did the same thing. So they wanted to have a language that had anonymous functions, so they built closures for Swift. And in doing so, they were like, well, we can move this to Objective-C, and we can put blocks in there. So these projects take a long time to come around. But finally it did. In 2014, last year, they announced at their keynote, that they introduced a new language, and that this was the way moving forward. I find it interesting that so the entire world almost nowadays watches Apple keynotes, and so I found it interesting that they wanted to mention such a technical detail, the language that we implement our apps in, at such a public keynote, right? Which I think is kind of an indication of what are some of the intentions Apple has with Swift. They want a lot more developers. They want an audience that can understand programming easier, and they've developed tools for it, which we'll look at. So when they introduced Swift, the hot new thing, they used 3 keywords to describe Swift. They said that Swift was safe, that Swift was modern, and Swift was powerful. So I want to look at some of the features of those languages, and a lot of these things, this is another thing they mentioned, none of these concepts are new. They're heavily borrowed from a lot of other languages, and it's very intentional, right? But I want to touch on some of those features if there are no Objective-C developers in the room, but to kind of convince you or to take a look at Swift and see why it's cool. So one of the biggest problems when you're writing software is that your data can change from under you, right? And there's all sorts of ways you can prevent those things. You can write tests for them, but certain languages make it easier by favoring immutability by default, right? And Swift is one of those, or it tries to be. Swift favors immutability over mutable data, so it's stuff that can change under you. Now Objective-C also did that, but it did that in a very convoluted way. So at the top you have some Objective-C code, and we're just creating a string. And now the first one is how you create an immutable string. You use the class NSString. But if you wanted to create a string that you can change, a mutable string, you have to use an entirely separate class, NSMutableString. And the problem is that both classes have some distinct set of API that the user then has to not only understand, like, okay, this is how I write with strings in Objective-C, but I need to know a certain set of API for strings that can change and a certain set for strings that can't. And it's the same for arrays. You have NSArray and NSMutableArray. And like with both, you can create a string simply by writing a string, but you have all that crazy @ symbols everywhere. But for a mutable string, to create it, you have to give it an initial capacity. And this is because of some of the stuff we talked about. The compiler needs to know how much memory you need, so it can allocate that memory and forces you to think about those things. In Swift, on the other hand, all you need to do to create immutable versus mutable data is to specify what type of, whether it's a variable or a constant. So using the keyword let, you create something that cannot be changed after it's created. It can never be changed. When you use var or variable, it changes, right? And it doesn't matter what class you're using or what object you're using. All you do is specify let or var, and that controls whether the data can change or not. And so this is so much easier for newcomers to understand, and it's so much easier for a developer when just reading through code to see, okay, this can change and this can't, rather than have to understand, like, what is this API, what is this class doing, is this thing changing as it goes through our code base.
Where does the let come from, the keyword?
Where did they use it from? Where did they borrow it from? I don't remember.
Var stands for variable, but let?
A couple of different languages use let for constants. I don't know which one they picked for that. A lot of people complain because I think a couple other languages use let for variables, and so it kind of gets confusing there. But yeah, they borrowed from a lot of languages in designing this. So yeah, I don't know exactly where it came from. And then Swift introduces static typing. So static typing, in contrast to dynamic typing, is where you have to specify, what type your variable or your class or your object is when you're creating it. So in Ruby you don't. You can just create a variable and it can contain anything. In Swift, so you see that code, like, you have to, name is always a string. Now Objective-C had static typing too, and so if you go back, you'll see I have to specify that it's a string, an NS string or an NS array. So Swift improves upon that by having type inference, where you don't have to write that. I can get rid of that string line, and it'll still know that it's a string. Now, static typing, there's this is like one of those flame war topics, static versus dynamic languages. But static languages that have static typing, the compiler can do a lot more work to reduce errors for you. It forces the developers into a more constrained environment, but again, when you think from Apple's perspective, bug-free code, better apps, better end-user software, right? And so over here, you have a compiler that can do more work for you by knowing that, hey, this is a string, so you can't call some integer method on it, or you're expecting something here, but you're trying something else. And it's also better self-documenting code. So as you're reading through code, if the types are explicitly mentioned, you know what's expected here in method calls and parameters and things like that. And my favorite part probably in Swift compared to Objective-C is how it deals with nothingness, or like the absence of data or values. So Objective-C was kind of built on top of C, and then it was improved on top of that. So there's a lot of different ways you can deal with the concept of nothing in Objective-C. So if you're dealing with C code, nothing is represented by null. If you're using Objective-C objects, which are like structs and those kinds of things, strings, then nil is how you represent nothing. If it's an Objective-C object, it's nil with an uppercase n. And there's ns null as well. So the problem is that when you're writing code, you need to know, hey, am I going to get a nil out of here? So let me write a nil check. Or am I going to get null? Or am I going to get ns null? So you need to know where these things are happening, and it forces the developer to hold this huge mental model in your head, which can lead to buggy code. In Objective-C, in Swift, so this is, I believe the inspiration is primarily from Haskell and the maybe type, but Swift has an optional. And an optional is a type that can either be nil or can have some value. The cool thing about optionals is that only optionals can ever be nil, right? And so when you're looking through code, now the way you denote an optional is you put a question mark. So it also makes it easier to kind of read, hey, is this value there, right? It's a question, really. So in this one, we have an optional string. That string can be nil. And then when you're writing code, you can chain things. So in Objective-C, you had to have like nil checks and say, if this is nil, okay, no, let me access this property. Over here, you can chain this thing where in that line of code, I want to get this is a contacts app, and I want to get John's street from his address. And I can say, if you open up your contacts app, not everyone has address information in there, right? Some people have residences, some have actual street addresses, and from that address, some people have a specified street string. And so in this line of code, I don't know whether those things will exist, so I can say john.residence with a question mark, .address, .street. And if residence exists, then address will be executed. If address exists, street will be called. But if any one of those are nil, the whole thing just silently fails, like it doesn't get executed. So it means that I can write code like this, and when it exists, I get what I need. When it doesn't, it doesn't crash my app. The cool things about optionals is that when you understand that only optionals can be nil and nothing else can be nil, like anything other than an option cannot be nil, then when you're looking through code, if none of them have if there are no question marks littered, then you know that these objects can never be nil, right? So you'd have to do less checks. You can reason about your code. You know that this data won't ever disappear out from under you at any point. So this is how Swift kind of brings safety to Objective to the iOS and Mac community. And then Apple claims that Swift is modern, right? So the first thing people are looking for in a modern language is syntax. To me, syntax is not particularly a big deal. I think after you internalize syntax in any language, you forget about it and you use it. I certainly wasn't complaining about Objective-C while writing it, but Swift does make things a lot easier, and this looks a lot more like, this is the exact same thing that we did in Objective-C and Ruby, but in Swift. And it looks more like the Ruby equivalent. In fact, it'll probably look more like JavaScript, which is where Swift is heavily influenced by JavaScript, and very intentionally, because almost everyone writes JavaScript code, right? It's ubiquitous. And so one of the design intentions of Swift was that Apple wanted people to come from any language and feel somewhat at home in it. This is familiar. Like I have to learn just a little bit more than the language I already knew. And so it takes inspiration from a lot of different languages to do that. And so yeah, it's a lot easier. You call car, you pass in parameters, and you call start. None of those crazy pointer stuff. Now the thing is, it's still the same tool chain under the hood, and Swift actually uses Objective-C under the hood. So it's doing all those things for you, but that's a temporary constraint as Apple improves on the tools. But there is a catch to that familiarity, right? So is this JavaScript or is this Swift? It's both, right? And so a JavaScript developer will come to this expecting the same behavior as JavaScript. So here, if this is JavaScript code, you have an array with strings in it. You call reverse, and you look for the first element in this array, and you're going to get B back, right? But in Swift, you're going to get A back. And the reason is because, again, Swift prefers immutability. So this is a little bit computer sciencey, but in Swift, other than classes, everything is a value type, which means that you don't actually mutate data, you don't pass by reference, you create a copy of that data and you work with the copy every time. So you have a new set of data for each operation, right? So you don't affect any other parts of the app. And an array in Swift is a value type. So when we call reverse here, we're not assigning the result of reverse to a constant or a variable. So we're still looking for at the first index, we're looking in the original strings, which has not been mutated. And so the data doesn't change. We just created a copy, but we got rid of that copy. And so if you don't know these little things, that's Swift, how it differs from other languages that look familiar, you can kind of get caught. But there's a lot of other things that make Swift modern. Objective-C never had this rapid prototyping environment, right? So we had to, when you wrote an app, you had to like build in Xcode, and as your projects get bigger, it takes a lot of time to build. I just watched a talk recently at Facebook where they said that to like build and run the Facebook app every time, it took 6 minutes. So every time they introduced even a single line of code and they wanted to test it, they would build the entire app, and you just sit there for 6 minutes and wait. And every time they opened up the project, it would take another 5 minutes, to kind of index the entire project. So you're wasting 11 minutes, basically every time you start up your computer and building the app. And so, Swift introduces a REPL, which all modern languages have, which is a read, evaluate, print loop, where you can, test small chunks of code kind of in the command line without having to build your entire app. And problems like that is why Facebook, I don't know if you're familiar with that, but Facebook is now using JavaScript to write fully native iOS apps. And this is part of the problem, right? Because Objective-C has all this baggage and it takes so long to compile. And then the rest of the stuff, they're all language features that Swift improves on. You don't have to think about memory management anymore. You have better support for like these anonymous functions. You can return multiple values, which you could never do in Objective-C. And then you have these generic containers that allow you to build very flexible structures that can take any type, and be kind of modified at runtime. Yeah, and then Swift, the last thing is Swift is powerful. So the thing that Apple will talk most about in terms of power is that it fully works with Objective-C. So even though it's a new language, you can write Objective-C and Swift code in the same file, and they'll, in the same project, and they'll run perfectly fine. It's, perfectly fine is their marketing term. There's a lot of like stuff you'll have to work through, but it's using the same tool chain under the hood. So there's a lot of projects that, like I believe our Treehouse iOS app, we've stopped writing Objective-C code, and we're just writing Swift from now on. It's the same app, but you can mix both. But the real power in Swift comes from the fact that they took inspiration from a lot of different platforms and a lot of different languages to make it a very flexible language, and what they call it a multi-paradigm language, right? So it can do a lot of things. Almost everything you can do in an object-oriented language, you can do in Swift, and almost all the stuff that you can do in a functional language, you can do in Swift too. So this makes the language a lot more powerful, and it means that no matter what kind of background you're coming from, whether it's an object-oriented or a functional background, Swift has something familiar to you. And so you can still continue your style of coding, now in the iOS community, and be able to build apps, right? Whereas there was a very distinct way you wrote iOS apps with Objective-C, and you had to get your mind around it. So it's really cool. A lot of people have been toying around with a lot of different ways with writing iOS apps in Swift. It makes teaching Swift a massive headache because we have to teach every one of those things now. But for developers, it's very cool. The last thing. So when I mentioned earlier that Apple really wants to bring beginners into the fold, when they released Swift, they released a completely new feature as part of the tool chain called Playgrounds. And Playgrounds is built from the ground up to be an educational tool, and it has become more of a prototyping tool now. But it's this It's an editor where your code is continuously evaluated and displayed. But it doesn't display it in the sense that like if you print out an array, it just prints it out. But it shows like every step of your code. Like if you iterate through an array, you can have a time graph that plots out how you're accessing the array elements. And you can see as a function steps through some code, how it affects each point of the data in time. You can map that out, and then you have like a slider on the bottom that goes through time, so you can play back the results and see how things change. It also allows you to prototype views. So this is some code that you can download from Apple's blog. It's called Balloons, and it's a playground where they're using their graphics rendering and animation engine to have this silly little game that where cannons shoot out balloons. And the cool thing about Playground is it's a living document. So it's not just an editor. You can have like text in there. So the idea is that classrooms will distribute playgrounds as part of your homework. And we do this at Treehouse too. When you take a course, you'll get a playground. And so you just you read what you learned about in your textbook, and the line of code is there, and it's evaluated, and you can change that code and see how it affects the entire program. So it's a lot easier to learn how to program. And Apple is doing all these things with their end goal in mind: more people writing iOS apps. So when I was trying to think about like how to summarize my thoughts on this, because Swift is cool, there's a lot of cool features, but the reaction from the community has been very mixed. And this is quite obviously, it's typical, like when you introduce a huge change into a community that has been doing this for a while, there's going to be some resistance. And then I watched this, especially with existing Objective-C developers, a lot of people I've talked to, their kind of feedback has been, oh, Swift is cool, but nothing compels me to move away from it to Objective-C, from Objective-C to Swift. And they're not even willing to try it, right? Because they think that Objective-C, there are no problems. I can write my day-to-day code, and I can do my job in Objective-C. Why should I even consider Swift? And then I watched this talk last night. This is a really good talk by Daniel Steinberg. He's an iOS and Mac developer, but so this phrase, I believe, is from a book that he adapted for his talk, and he talks about the ugly American, right? So the conference he was talking about, it was in Paris, and he was referring to himself as the ugly American, and he said, so the ugly American comes to Paris, and he wants to get a drink, and so he's walking past cafe after cafe after cafe, serving, wonderfully roasted French coffee and, beautiful pastries, and he goes to Starbucks. And then, this American, keeps walking, and he's hungry, and he's going after restaurant after restaurant, like world-class restaurants with renowned chefs serving wonderful food, and he goes to McDonald's. And this is not what makes the ugly American ugly. What makes the ugly American ugly is that he goes back home, and people say, "How was Paris?" And he's like, "Meh, it was about the same." The message is that basically when you come to Swift, or when you come to a new environment, but you're expecting to do the exact same thing that you do in your environment in this new language, then you're not going to see the benefits of the language. So like if you come to Swift saying, I want to write, oh, why can't this do what I do in Objective-C? You're kind of missing the point. Or if you come to Swift from a functional background and you say, this is not really a functional language. Haskell can do so much more. Then you're kind of missing the point that this language, when you look past that, is very powerful. You can do things in so many different ways that is very flexible, gives developers the opportunity to experiment in different paradigms and development methodologies that without having to leave your platform, right? So, prior to Swift, if you wanted to learn functional development, you couldn't do it in iOS and Mac development, right? So you had to go to a separate platform and learn all their stuff. But now you can, and that's what makes Swift really cool. So his message was that as existing Objective-C developers, you should pretend that Swift is basically a brand new environment, and try to embrace it and learn new things and learn how you can be a better developer using these tools rather than saying like, oh, it's just a different kind of hammer, right? What does this mean for? Oh yeah. This is, unfortunately, so I wanted to talk about, what does, I want everyone to try Swift, especially iOS developers, but there aren't any in the room. So I wanted to talk about what does it actually mean, so if you were doing iOS development here at Skookum, should you start writing Swift code? And unfortunately, it's kind of risky. and not because the language isn't good, but because the tool chain isn't there yet. So this is something that when you're writing Swift code, you'll see quite often. Not so much anymore as Apple's iterating, but Xcode crashes constantly. And like basic things like syntax highlighting just disappears. And yeah, so Xcode has a long way to go. Like some of the tools have ways to go, but you know, they're iterating on it very fast. Like a lot of people have been like criticizing Swift as a language without realizing that it's not even a year old, right? So it's got a ways to go. But you know, so since there aren't any iOS developers, you know, if you are interested in iOS development, so this is a question I get at Treehouse quite often. Should I learn Objective-C or should I learn Swift? Tim Cook runs around saying this, which I think is a huge lie, because iOS development, you know, once you know the language, and that really isn't the hard part, right? Like, yeah, Objective-C, there were some hurdles, but learning the frameworks and the SDK of iOS is a conceptually much harder topic, because you have to keep, you know, a larger mental model in mind. So Swift doesn't really change that, but Apple has clearly indicated that like Swift is the future, and Swift is a lot easier, you know, for beginners to use. Up until very recently, we told our students that, oh, learn whatever you want. You know, Objective-C is not going away anytime soon, so learn Objective-C. And I mean, for the next at least 5 years, if you get hired as a junior developer, you will be writing Objective-C code. You won't be writing any new apps. You'll be working in an existing code base, and you'll need to know that stuff. But then, you know, WWDC, Apple's developer conference in June, they just announced their little ticket lottery last week. And the interesting thing was, so they have a student section where you can get scholarships without having to pay the ticket price. And typically how you enter the scholarship is you write an app and you submit it. If they think it's cool, they accept you. And the interesting thing this year was that the app had to be in Swift, or it had to be primarily a Swift app with some Objective-C code, but it could not be an Objective-C app. So Apple is clearly moving forward, you know, with Swift. And what's interesting to look at from even outside of the community is how fast they're kind of pushing that change. You know, everyone expected Objective-C to last for a while, but I don't know, maybe, you know, with rules like that, you know, Apple obviously, you know, they pass their blanket rules without any concern. So at some point they might say, yeah, just, you know, write Swift code now. So as a beginner, I think you should really start learning with Swift, and then once you have the basics of you know, iOS development, you can write. You know, some of the problems that you run into with Swift, those little editor crashes, they won't happen when you're writing toy apps, you know, that you kind of learn with. It's when you start to get into large code bases. And so, yeah, you know, start learning Swift, and once you get the hang of iOS development, then, you know, take some time if you want and learn Objective-C. So that's kind of what I want to talk about. Hope it wasn't too rambly. But I wanted to talk more about like the change, you know, that the community is kind of going through and like some of the reaction for it. Go ahead.
I told my colleague I was interested in learning Swift, but he suggested that my time would be better served to just focus more on continuing with JavaScript because all those apps can be written in JavaScript. Can you comment on that?
He can. So. Yeah, so the question was, so she wanted to learn Swift, and one of her coworkers said that, you know what, continue working in JavaScript, because you can do all that in JavaScript now. And you can, but I haven't taken the time to play around with it, but he has, so.
Yeah. So there's the React Native approach, where you actually build native apps with JavaScript, which is really neat. Of course, I'm a web developer, and I'm biased, because I also love React, so that definitely was for me. But I would highly recommend going like the Swift, like the native route over phone guy. So.
Yeah, and the thing is, I mean, if you know, you know, kind of what it's doing under the hood, and then you go and write JavaScript, you know, that code that generates a native app, I think that's fine. But if, you know, you plunge straight into it with JavaScript and then you have to debug Objective-C code, that gets really technical and difficult, right? So, because what the React Native does is it still spits out an Objective-C app. So yeah, so you know, they're doing some really cool stuff in that space. But. Any other questions? Go ahead.
Yeah, could you comment on an overly simplistic view of the last 30-some years? Stage 1, most serious programmers have production experience at C. The API's in Pascal. Stage 2, C++ is coming on strong. Objective-C. Stage 3, even 12 years ago, JavaScript is coming on strong. Swift.
So summarizing 30 years is hard because I haven't been doing this that long. But I mean, I think Swift is trying to meet these more modern, bring this platform into the modern age, and I don't think it's trying to necessarily get rid of that, the C background. That depends on how Apple wants to do it, but it'll take a long, long time for them to rewrite all of iOS, and the Mac platforms in Swift. And so I think that I think it's more of like an iterative experiment. I don't think they expected the community to adopt Swift so fast, and so I think that that language that it's really not going away for a while. But I think it's their attempt at using a more modern language that does more for you. I think back when those languages, their advantages are memory-constrained devices where you're writing low-level code that really allows you to be quite more flexible, less abstracted, right? But as I mean, you're writing an app in JavaScript, right? You're clearly not thinking about those issues, but it's still possible. And so, Swift, I think, is an attempt to kind of meet in the middle, where you still have some control over those things, and you can get low level if you want to, because you can still write C code in Swift, but you don't have to. Not everyone needs to, and so. Yeah.
Well, yes, my point was, if you have skills in the broader community, it seems like there's a glass wall to this community.
Yeah.
You have to learn different things than almost everyone else is using.
With Swift?
Well, just at every step.
Yeah, and I think that's just the nature of the field, right? I think like everything is so constantly changing that, I mean, I've been really writing iOS code for maybe 3 years tops, and so I just started to get comfortable with Objective-C like now, and so and now Swift is the thing. And I mean, I spend my time mostly in Swift now, primarily because we teach that at Treehouse, and so yeah, I mean, there's a lot of things that you expect to work in Swift, or like just design patterns or simple things that you're so used to with object-oriented programming that isn't the Swift way of doing things, and so you have to kind of just shed all those preconceived notions and kind of be willing to relearn all those things. So yeah, I think that's kind of the nature of the field, right? Anyone who's been here longer than me can probably attest to that. So.
And how about developing Swift apps in other environments than MacBook?
Probably not going to happen, only because, well, it depends, I can't say. So like, if you look at the tool chain, so you have the compiler underneath is open source, right? So LLVM is the compiler infrastructure for everything that runs on the Mac and iOS, and that is an open source project that's led by Apple. So I don't know that they may open source. There's 3 things they have to do for you to be able to run Swift outside of the Mac, and that's open sourcing the compiler, open sourcing the runtime, and then open sourcing the language. And the compiler and the runtime are already open sourced, but it took them like 20-something years to open source the Swift runtime. The Objective-C one. I think it's mostly because they didn't care to put effort into it. But Apple's changing. They just threw up one of their frameworks on GitHub the other day, which is like unprecedented for them. So who knows, maybe. I mean, so when we asked that question when we were at the Swift Summit, and they said that they would love to, but that's like the Swift team would love to open source Swift, but that's outside their control. So that's a decision that Apple will have to take.
Because it's kind of contradictory, because on one hand they want more developers.
Right, they want more developers in their
Exactly.
walled
And
garden,
they
right?
force you to buy MacBooks to use
Right.
MacBooks and that.
Yeah. Yeah. I mean, I think that that's Apple's big philosophy, right? Like their walled garden. So I think that they do open source quite a few things. WebKit is open source, but yeah, I'm not holding out for Swift to be open source and to be able to write on another machine. I mean, that's where things like React Native become really cool, to where you can create iOS and Android apps soon, pretty much on any platform. So yeah, there are ways. But there's Ruby Motion, there's a lot of things. But yeah, I don't expect Apple. I think the only piece of software that Apple makes that doesn't work on a Mac is iTunes, and and I don't know if it's a great piece of software, but I can't imagine that with all the problems that they're having on the Mac, that they're going to tackle supporting another platform themselves. So yeah.
Related to that question, sorry if I cut someone off. What is Swift useful for besides iOS apps? Make sure I have to write it on that. But can I build web services?
Yeah, so there's a repo out there where someone's building a web service in Swift. It's called Taylor. And
Already.
yeah, and so yeah, I think people are trying different things, but just because we don't have access to the Swift runtime, so it makes it difficult. So yeah, but yeah, I think people are trying to take it out of that, the iOS world, kind of bring it out and do more. So yes.
When you say that it's changing rapidly, they're iterating rapidly on Swift, I agree because they keep changing, how that works across every single
Right.
type of declaration. They're also changing like the way variables are declared.
Mhm.
So when I'm thinking of a new language, I'm thinking of a language that won't change in 6 months.
Right. I mean, I think that's very temporary. I think their developer conference is in like 5 or 6-ish weeks, and they may announce that okay, Swift is final for now, and we're not going to do a lot of changes. A lot of the changes they're doing now is to improve how. So the other thing they had mentioned was that Swift was a very secret project, right? So when we went there, I had never been to Apple before, so I was exposed to the typical Apple stuff. Someone badged me into the first floor, but he couldn't get into the second floor, so someone else came in and picked me up for the second floor, and we had to sign all sorts of NDAs for that week. But I think only under 150 people in the entire organization knew about Swift when it was announced on stage at WWDC. So like all the people who were giving all the other talks had no idea that this language had existed. And so when we were there, we were in like this conference room, being told about Swift, and another Apple employee tried to enter, and they were like, "Nope, sorry, you can't see. This is like you're not allowed to see this stuff." So so Swift is untested, to answer your questions, in terms of building iOS apps, and so a lot of the changes they're making now is reflective of how the community is using Swift and how it's breaking, right? So like a lot of the things were more like. There's been very few changes in terms of like some of the beginner level stuff. Like how variables are initialized, that's a big thing. But most of the optimizations were how your sorting works, or how you're accessing stuff, and just optimizing the compiler to do more things. Because when you start to compile large Swift apps, it takes a while, and so they're improving on that stuff. And I think some of the other improvements are in terms of like being a multi-paradigm language, they're adding more functional stuff. You can still write object-oriented apps, but not, they just added like flat map to the standard library and map, and so yeah, they're iterating in a bunch of different ways. But I mean, if you look at probably any language when it first started out, it must have changed constantly for the first 5 to 6 years, but it wasn't as popular, right, as Swift is now, because Apple is pushing Swift with marketing power and not just like developer stuff. So yeah, I mean, I'm sure any language when it started out went through years and years of iteration before it was a 1.0, and so yeah, I think that's part of the issue. Apple kind of pushed it out before it was ready, but also I think it's a good approach in that now one of the cool things that iOS developers like about Swift is that we're able to influence the direction that Swift is taking. So if you go into the Apple developer forums, there's people like it's very unprecedented for Apple employees who are working on these projects to really communicate with the outside. But if you go into the developer forums and you go into the Swift section, people will complain about an issue, and then you'll have the the guy who's in charge. Oh yeah, that's the last feedback I had. He's the guy in charge of the Swift project, and this is kind of like the most common feedback from the community is that Swift doesn't work. Swift's broken, so I don't want Swift. But it really isn't 1.0 yet, and there's a lot of work that they're doing. I mean, it is 1.0, on paper, but in theory, like they're doing a lot more work to get it better for you to write apps. And yeah, so I think it's got a ways to go in terms more of the tool chain and being production ready, but it certainly will change. Believe me, it is a huge issue at Treehouse because we release courses in video, which is an annoying format to update, but it makes it easy to learn. And so in September, I released like 7 hours worth of video. In December, I had to update all 7 of those hours. And now, because the language completely changed, right? And they're not changing just the language. Like when all the Objective-C API is brought into Swift, they're changing they're auditing is what they're calling it. Because in Objective-C, you can pass nil in so many different places, whereas in Swift, only optionals can deal with nil. So they're really auditing the API to see when we bring this Objective-C code into it, how is Swift going to interact with that, if you're writing Swift code. And so they're constantly changing a lot of little things that as a beginner, you have no idea what's going on. And as a beginner, you think I'm doing something wrong, rather than, this is something Apple's working on. And so we're constantly having to update for even minor changes in the language. So yeah, it is a huge pain. But.
So why not just wait like a year to start doing
I think to teach it, because we'll lose customers, because everyone wants to learn Swift. So one of the interesting things, so at that Swift summit, there were tons of people there, right? So Khan Academy was there, Udacity was there, all the big names in these online schools. And if you're from the iOS developer community, raywenderlich.com is this big website with an enormous amount of iOS resources. We're one of the few people who left that, few companies who left that event saying, we're going to continue teaching Objective-C and Swift. Everyone else teaches only Swift now, because this is also one of those instances where Apple's pushing this language, but there are no resources for it. And so whoever gets to the front of that, is going to be very prominent in terms of being a thought leader, or one of those terms for the language and teaching you how to build iOS apps in it. And we track our students. We offer both. So when I teach a course, so I'll teach you how to make a weather app on Treehouse, and I'll produce the exact same course in Objective-C and Swift. And the whole site's gamified and all that nonsense. So every time someone unlocks something, it unlocks a badge. And so the course has been out for 4 months. Objective-C has like maybe 7,000 badges unlocked, where Swift has like 32,000. So way more people are interested in taking Swift stuff and are coming looking for Swift than for Objective-C. And that's primarily because they don't know. Apple's pushing it, so they assume that that's what they need to know, right? So, but to answer your question, like most people, most companies are not writing Swift code. They're going to wait it out until it's ready and then jump into it. We'll talk.